What if we took every last atom of uranium-235 on Earth, made one giant nuke, dropped it into the Mariana Trench, and pushed the button? Would we blow up the Earth? Let's break it down. First, the location. The Mariana Trench sounds epic, right? The deepest place on Earth. But let's get some perspective. If the Earth were the size of a basketball, the Mariana Trench would be a scratch on the surface, less than 0.2 millimeters deep. It's not a crack in the planet, it's a dimple. So detonating a bomb there doesn't make a difference. The real question is about the bomb itself. Okay, so how much U-235 do we have? Our proven mineable reserves are about 58,000 tons. But there's a problem. A few, actually. First, you can't just pile 58,000 tons of U-235 together. It has a critical mass of 52 kilograms. Anything more than that, and it starts its own chain reaction. You wouldn't have a bomb, you'd have a very messy, premature fizzle. Second, nuclear fission is shockingly inefficient. The little boy bomb dropped on Hiroshima only fissioned about 1.5% of its uranium. Modern bombs are better, but still only hit maybe 20%. But let's ignore all that. Let's say we have alien cheat codes and can make all 58,000 tons react with 100% efficiency. The energy released would be about 4.8 times 10 to the 1% joules. That sounds like a lot, but how much is it really? The asteroid that wiped out the dinosaurs, it hit with about 4.2 times 10 to the 1%, 2 joules. That means our all the uranium we can mine bomb is just 1% of the power of the dino killer. It wouldn't crack the Earth, it would barely scratch the paint. But wait, you say, that's just the uranium we found. What about all of it in the entire planet? Great question. You found the loophole. Earth's crust and mantle are loaded with uranium. If you could gather all of it, you have about 2 trillion tons of U-235. Now we're talking. Let's use our alien tech again. 2 trillion tons of U-235, 100% fission. The energy released would be a staggering 1.6 times 10 to the 1% joules. That's like 380,000 dinosaur-killing asteroids hitting at once. Surely that's enough, right? To answer that, we have to introduce the final boss. Earth's gravitational binding energy. This is the raw energy holding our planet together. It's the minimum amount of power you'd need to completely overcome Earth's gravity and shatter it into pieces. That number is a fixed value, 2.24 times 10 to the 1% joules. So let's compare. Our ultimate theoretical impossible nuke, it has less than 0.1% of the energy needed to crack the planet. It's a firecracker trying to demolish a skyscraper. The takeaway? Our planet is an absolute tank. It's incredibly tough and ridiculously hard to destroy.